All right, so this is the last lesson that we're doing today. So it's applying center and variability. So we've learned a lot about symmetric and skewed data. So symmetric data, as you can see, is evenly distributed. Sometimes it looks like a bell curve, or it can also look like an inverted bell curve, okay? Either way you cut it, those it's going to look, symmetric, but that one doesn't. Versus skewed data, right? Which this one is skewed right, because that bottom point, the lowest point is over here. The one with the less, with the least amount of frequency is over here to the right, and this one is skewed left here, okay? So looking at center, so if it's symmetric, looking at the mean, it shows where the center of the data is. It's not always a true representation of the data, because sometimes the data is skewed, and sometimes, so it may be better to use a median, okay? So a median is the midpoint. It may not be a data value, because like if it's an even, then we find the average of those 2 points. So like if we have a even number of data, let's say we have 10, then there's going to be 2 numbers in the middle. Remember, we take the averages of those numbers. So yeah, and it does not have to be in the middle of the range of values, okay? So the median is just it doesn't have to be in the middle of the range of values. So MAD is a way to measure the spread in relation to the mean, like how far away are these numbers from the average. If the MAD is close to 0, that means the data is close to the mean. Another way to measure variability is IQR, which is interquartile range. So when we have those box plots, remember we subtract Q3 and Q1. It's a way to measure the spread of the data around the median, right? And if it's a small IQR, that means that the data is very close to the median, okay? So, and some graphs that we learned about were histograms, dot plots, and box plots. The school nurse measured the height of each student in Miss Matthewson's class. She then created a histogram to display the data's height. So you can see the range from 40 to 44 inches. How many people do we have here? Let's see, 1, 4 people here. A lot of people at this height. Okay, so that's 6, that's 7 people here, and then 5. And then there's about 2. All right, so the shape of the data. So if I look at the shape of the data, I would definitely say that it is symmetrical, okay? Because again, it's giving bell curve. All right, so we can see it's evenly distributed. It has a peak here, and then it kind of distributes and goes down. So this one is definitely symmetrical. It says, what is the best measure of the center, okay? So because this data is symmetrical, the best measure of the data is going to be the mean, all right? And so the best measure of variability, because if the best measure of center is the mean because it's symmetrical, so how do I measure variance for a mean, right? I would use the MAD, okay? So I would use the mean absolute deviation, which is also known as MAD. And then Javier says the mean will fall between 50 and 54 inches. Do you agree or disagree? So I would say yes, because the data is symmetrical. Because of that, the mean will probably fall in the middle of the data. Not SATA, data. All right, 2 studies were conducted at different banks. The summary measures how long a customer had to wait in line. So I'm looking at State Bank. The mean is 8, and the mean of absolute deviation is 6. And the National Bank, the deviation is 1. Okay, and so let's talk about why this matters. Okay, So we can see here, like, the mean is the same. So both of these banks can say that the average wait time is 8 minutes, but like you have to look a little deeper because all data tells a story, okay? So if the mean absolute deviation is 6, okay, that means that the data could be 6 points in either direction from 8, okay? So if I do 8 plus 6, okay, that means that that could go up to 14 for wait time. And if I did 8 minus 6, okay, that would, because remember this is distance, right? And we know the answer is positive. So if I do 8 minus 6, it would be 2. So that means that I could be waiting for like as little as 2 minutes, as much as 14 minutes, okay? But National Bank, the mean absolute deviation is 1, which means that the times that they pulled, right, because 0 would be, like basically everybody got 8 when they, for their wait time. But the mean absolute deviation being 1, it's very close to 0. So that means like all of the wait times are very consistent with 8, okay? Versus State Bank, okay? The math was 6. That means that the points for waiting, they were kind of like all over the place, all right? So that's why you have some variability between 2 to 4 minutes for State Bank. National Bank, if you do 8 plus 1, you would get 9. And if you do 8 minus 1, you would get 7, okay? So for National Bank, I'm waiting between like 7 to 9 minutes, okay? And for State Bank, like I said, I'm waiting between 2 to 14 minutes, okay? Now, it's possible that I, like if I go to State Bank, I could wait 2 minutes, 3 minutes, but it's also possible that I could be up there for 14 minutes, okay? So, that's what the data means, okay? It tells you kind of like the range. And at which bank would you rather stand in line? I think I would rather stand at National Bank because it's more consistent. I know I'm not going to probably be in there like much past like 8 minutes. And then State Bank, it just depends. Like you don't know what you're getting. Okay. So I'm going to go ahead and type this out. All right. If I wanted consistency, I would stand in line at National Bank because the range of wait times is closer to like 7 to 9 minutes. And then at State Bank, the wait time varies from 2 to 14 minutes. So I'm kind of not interested in that. Citibank, a new bank in town, advertises that they have quick lines to satisfy busy customers. But are you lying? The data shown below compares the wait time for 10 different customers at both National Bank and Citibank. Okay, so we're not even rocking with State Bank. Okay, it says sketch a dot plot with the same scale to compare the wait times. Okay, so because these numbers went from 3 to 10, that's why these go from 3 to 10. So starting with National Bank, the first one is 5. So I'll put a dot here. 7. 1, 2, 3, 4, 5 8s. There's going to be 1, 2, 3, 4, 5 8s. Okay, 2 9s. Okay, and then 1 10. Okay. At Citibank, I have 2 3s, 4 5s, and I got 1 7, 1 8, 1 9, and 1 10. Okay. So when you sketch your dot plot, it should look a little something like this. So remember, if I was to find the mean, I would add all of these up and I would divide it by how many numbers there are, which is 10. Okay. 1, 2, 3, 4, 4, so here. Okay, so you just add all this up divided by 10. If I was finding the median, I would just be finding the number in the middle. Like these are already in order. So you would just, like cross until you got to the middle. Obviously, it's going to be 8, right? Because there's nothing left but 8, but okay? So we can see like the median here is 8. And because it's the same amount of numbers, like I'm going to have to cross out 4 on this side and then 4 on this side. And so you can see here that 5 is going to be the median for Citibank. Okay. Okay, so I just kind of wanted to talk about like some things with the data. Another thing I want to point out is what is the mode for National Bank. And so you can tell from the dot plot that the 8 goes up the highest, and that's reflected here with 5 instances of it. And then for Citibank, you can see that the mode is 5 because the frequency of people that have waited for 5 minutes is 4 on here. So looking at Citi, it says calculate the mean number of minutes in line. Okay, so I already know that the mean for National Bank is 8 because that's what it said in number 2. So I don't have to calculate that. But for Citibank, I just added these up. This says 20 because there was, 4 frequencies of like 5 minutes. So I just did 5 times 4 and I put 20. So when I added these all up, I got 60. And then when I divided it by 10, because there was 10 data points, the mean for Citibank is 6, and the mean for National Bank is 8. So it says, does Citibank live up to their advertisement? Okay. And so if the mean for National Bank is 8 and the mean for Citibank is 6, on average, Citibank customers wait 2 minutes less than National Bank customers, okay? So now we're going to dig a little deeper and look at the variability of this by comparing like the wait times, like the actual wait times to the mean using the mean absolute deviation. Okay, so first what I have to do is I have to, I already know what the MAD is for National Bank, okay? But for Citibank, I just take the mean and I subtract it from those data points to see how far away it is. And then I find the average of that. Keeping in mind that it says mean absolute deviation. So it's how far away it is. So it's going to be positive because we're talking about distance. Also because it says absolute. So it's like absolute value. So like 6 minus 3 is 3. 6 minus 3 is 3. 6 minus 5 is 1. 6 minus 7 is 1. So this is 2, 3, and then 4. All right. So I'm going to add all of these up. And so when I add these up, I get 6. This is 7, 8, 9, 10, 11, 13. 11 plus 12 is 13. 13 plus 3 is 16. And so this is 20. Okay. So I'm going to take all of these and then I would divide it by how many data points there are, which is 10. All right. So on average, I can see that the MAD for Citibank is 2. Okay. And then we know that the MAD for National Bank is 1. Okay. So this is the MAD for National. And I know that because it says so in the last problem. So remember, we said on average that range for National Bank was 6. No, it wasn't. We said it was 7. We said it was 7 to 9 minutes, right? Because if the average is 8 and the variability is 1, we said it'd be 7 to 9. Now you can see on here, actually, like we have one instance of 5, okay? But again, it's mean absolute deviation, okay? So we're finding the average of those changes. And you see right here, we have a 10. So it's not always, this is just on average, just trying to give you a better idea with that variability, okay? For National Bank, for Citibank, excuse me. So if the MAD is 2, I know that on average, basically, because this is 6, so it's going to be 4, between 4 minutes and then 2 minutes more than 6, which is 8 minutes, okay? So again, we're doing that plus 2 here and that minus 2 here, okay? And that's how we got 4 to 8 minutes. And again, I want you to see there are no instances of 4 right here, okay? It's, but there are some instances of 3. And again, there's an instance of 9 and 10, but that's not, on here. So again, it's just giving you an idea. It's not, exact. So let me answer the questions. I would say Yes, on average, Citibank customers wait 2 minutes less than National Bank, right? Because this is 4 and this is 7, but like looking here too, like you can go from 4 to 8, right? And then here you can go from 7 to 9. So you can have a smaller wait time, but it won't go above the wait time for National Bank. Okay. You can also see that this is 6, this is 8. So it's 2 minutes less. If you wanted more consistent wait time, which bank should you use? So we talked about the MAD and how the MAD for this one was 1 and how the MAD for this one was 2. It says National Bank is more consistent, right? Because that range is 2. Okay. And Citibank has more variability, okay, because the MAD is bigger. But I mean, again, like 4 to 8 minutes versus 7 to 9, like 4 to 8 minutes is better. Like it's fine. So because you also have an opportunity to, for the most part, wait less, and then you can see that here, like it's 8, right? That's that median. Excuse me, the number you see the most, and then the 5. Okay, so yeah, I would rather go to Citibank, but so I hope that makes sense. And I'm gonna stop it here, and I'll come back and add the homework